In today's video, I'm going to talk about how to translate the sine and cosine function up and down or left and right. Let's do a quick review on what we learned the other day. We learned the other day that the absolute value of a gives us the amplitude, or the height of the graph, that the period is equal to 2 pi divided by b. And remember, when we were talking about amplitude, that even if this a value is negative, all that means is that the graph is flipped over. The b value is always going to be our coefficient on x. And in order to fully understand horizontal translations, we need to make sure that our b value is factored out of the equation. In problems we did the other day, b was already factored out. Starting today, it may not always be factored out, and if it isn't, that'll be one of our first steps. The horizontal translation can be found by looking at the number that is added or subtracted to the x value. Now, if you recall from Algebra 2, when we have something inside parentheses such as this, the minus sign is part of the equation. So if we were to see an equation like y equals cosine of x minus pi thirds, in this case, d is actually positive pi thirds, and we would be moving to the right. If we saw a similar equation where we had x plus pi sixths, in this case, d is actually negative pi sixths, and therefore we'd be having a movement to the left. So remember that when we see a change inside the parentheses, we kind of have to think the opposite in terms of getting left or right movement. For these four graphs, please identify the amplitude, period, and translation left or right. Unpause the video when you're done to check your answers. Alright, so when we're determining the amplitude, we want to look at that lead coefficient in front of the sine or cosine function. Recall that if the coefficient is negative, we ignore the negative sign. When we're trying to find period, we do 2 pi divided by the b value, and the b value is the coefficient on x. When we're trying to figure out our phase shift, which is what I've abbreviated PS, that stands for phase shift, we're looking at any number being added or subtracted to the x. One that I want to point out here is d. In d, the phase shift, or the b value has not been factored out. So the first thing that we need to do is divide it out of the 2x and the pi thirds. Now you'll notice here on the right that I'm writing that as divided by 2 to help us see that after we divide the 2 out, we get the pi sixths. A common mistake that people make here is they actually multiply by 2 instead of dividing by 2. You can double check your work by mentally distributing that 2 back, and we would see that by distributing the 2, we would still get 2 pi sixths, which gives us pi thirds, the original value in the problem. The next part we need to talk about is how to scale the x-axis. We learned the other day that we are going to find the period and then divide by 4 to figure out how much each tick mark should be worth. However, if we have a phase shift moving us left or right, this is changing our starting value so that we're no longer starting at 0. So here's the steps we're going to go through to find the scaling or the labels for the x-axis. First, we are going to factor out any coefficient on x, and this is going to be the b value. Next, we're going to find the period for the graph. Recall we get that by doing 2 pi divided by b, and then we're going to divide it by 4 to get the spacing, or the scale, for the x-axis. This is going to be the increment amount that we will use as we increase values along the x-axis. After we've done that, we are going to label the axis with a total of 5 tick marks. Previously, we only had to label 4 tick marks. That's because our first tick mark started at 0. Now that we are shifting off of the 0, we will have 5 tick marks in total. One of them may be on the 0, but it may not. It just depends on whether or not 0 ends up being one of the values that we get as we increment our axis. And it's important to note that the first tick mark will equal the phase shift amount. So for example, if I'm going left pi thirds, my first tick mark is at negative pi thirds. If I'm going right pi fourths, my first tick mark will be at positive pi fourths. Then we're going to use the scale to get the next 4 tick marks. So after we mark our first tick mark at the phase shift, we are then going to repeatedly add however much our scale amount is to get the next 4 spots. Alright, let's go ahead and give this a try with the example provided. First, we have to factor out the 2. So my equation will become y equals sine of 2 parentheses, and then we're going to divide the 2 out of each of these, giving me x plus pi halves. Once I have that done, I can do my pre-planning. My pre-planning is figuring out my amplitude, period, scale, and phase shift. For this graph, my amplitude is going to equal 1 because there is no multiplier in front of sine. The period is going to equal 2 pi divided by b, which is 2, so that gives me pi. My scale, which is the period divided by 4, will be pi divided by 4, or pi fourths. My phase shift, which is found by looking at the number inside the parentheses, will be left pi halves. Alright, so now when I go to do my graph, I'm going to start pi halves to the left. So we'll start over here at negative pi halves. My vertical scaling is going to be up 1 and down 1. And I'm going to move horizontally across my graph using a scale of pi fourths. Now, one of the things that I will often talk about is figuring out our fraction work underneath the graph and off to the side. Since my first point is pi halves and my scaling is pi fourths, we want to think about this in terms of the same denominator. So I can think about this first value as a negative 2/4 pi. And then I'm going to add a positive 1/4 pi several times in a row. So adding 1/4 gives me negative 1/4, adding 1/4 again gives me 0, adding another 1/4 gives me positive 1/4, and then lastly positive 2/4. We always want to make sure that the values we write along our x-axis are written in reduced terms. And I find that by listing them off to the bottom first, we can do our quick arithmetic, and then we can reduce our fractions and put them on the line. Now that we have everything labeled, we can go ahead and actually graph our function. So we were dealing with a sine graph, and sine graph always starts on the 0, so we're going to follow that pattern of 0, 1, 0, negative 1, 0. So my first point is 0, then positive 1, 0, negative 1, and then back at the 0. And then we can go ahead and sketch our curve through those points. For our next graph, we're going to skip down to example 2, and we're actually going to change this function to become a cosine graph. Alright, so if we do our pre-planning, we can see that our amplitude equals 2 and that the graph has been flipped. We can see that the period is equal to your typical 2 pi because there's no multiplier on x. If we figure out our scaling is going to be 2 pi divided by 4, which gives us pi halves, our default scaling if there's no change in the period, and my phase shift is equal to pi 6 to the right. So when I go ahead and start drawing my graph, we don't have as much on the left side now because it's a positive phase shift to the right. My first point is at pi 6. And my vertical axis is labeled to positive 2 and negative 2. Alright, so because my scale is pi halves and my first point is at pi 6, I'm going to represent my scale in terms of a denominator with a 6, which would be 3 pi 6. And the reason why I want to do this is because now when I figure out my fractions off to the side, each time I'm going to add 3 6. So my next tick mark would give me 4 6, 7 6, 10 6, and then 13 6. And now, when I label my axes, I can write these in reduced terms. So I have 2 pi thirds, 7 pi 6, 5 pi thirds, and then 13 pi 6. Because I'm dealing with a cosine graph, my first point is usually at 1, then 0, then negative 1, then 0, then 1. However, I have an a value on this graph of negative 2. So what that means is that the points I'm going to graph are actually negative 2, 0, 2, 0, and negative 2. This graph has been flipped over, and my first point starts low. Also notice that since my graph has been shifted off of the 0, I don't actually have a point on the y-axis. So the points that I'm graphing are going to be right here. And now I can go ahead and I can sketch my curve through those points. A couple things I just want to point out looking at this graph. We talk about the range of a sine or cosine function is from -1 to 1. However, since this graph had a change in amplitude, that changes the range. So this graph has a range of -2 to 2. Some other things that we'll talk about with this graph are maximum and minimum points. And the points that are the highest of the graph that have a y value equal to the maximum of our range are considered maximums for the function. And those points that are on the low end of the graph that have a y value equal to the low value of the range are considered minimums. Sometimes we'll ask you for an ordered pair for those locations. So if we look at this function, an ordered pair for my maximum would be 7 pi 6, 2, and an ordered pair for my minimum would be at either pi 6, -2, or I could also give 13 pi 6, -2. There's an infinite number of points we can list for max and min. However, we typically will just ask you for one of them that's in the first period you would have graphed. The last thing that we'll talk about is a vertical shift up or down. When we do a vertical shift, this is going to move the entire graph up or down, and we will see a number on the outside added to the function. This number could be written in front, like we see here on the example, or it could be written at the end. We typically put it in the front because then it's not confused with being a phase shift. Vertical shifts are rather easy. We're going to scale our x-axis the same way we've been working on, and then basically we're going to take our whole graph and slide it up. So if we look at this problem here, my typical cosine graph has 4 tick marks taking me to 2 pi, and a typical cosine graph has a point at the 1, the 0, the -1, the 0, and the 1. So it would look like this. Now if I'm going to put in place a vertical shift of up 2, what now happens is that my new 0 line has actually been moved up 2. And instead of having a range that goes from -1 to 1, my range has now been moved up 2, so it actually goes from 1 to 3. And so now my graph is going to look like this. High, 0, low, 0, high. The shape of the graph is the same, the only difference is that the whole graph has been moved up 2. When we're trying to figure out values for vertical shift or amplitude, what you can do is figure out the value for the high part of the graph, the value for the low point of the graph. Your vertical shift will be right in the middle, and the space between your vertical shift and either the high or your vertical shift and the low will equal your amplitude.